All right, line A1, learning task 18. This is going to be problems to solve with capacitive resistance. And once again, like the inductive resistance one, or the inductive reactance, I should say, this one is not going to be me going through each of the individual examples. The examples are good. The examples are going to go and explain their step by step. And if you have questions, we do that in the follow-up one for how they are. Go through them because they show how a bunch of the questions are done. And trust me, I got loads of questions similar to all of these ones. They're going to ask things about, a series of them together and what's my total capacitance? Or what's, the capacitive reactance? How does it change when we change the frequency of our components? This is actually a really big deal to us as electricians, knowing how stuff changes as we change over frequency, because when we change frequency, it changes all of our components. And we'll see that inside of our XL as well as inside of our XC, our capacitive reactance and our inductive reactance, because both of those formulas have to do with frequency, which means when you buy a European motor rated for 50 hertz, or an Asian motor rated for 50 hertz, or some of the South American motors that are rated for 50 hertz. If you buy anything that comes from out of country, big fancy pieces of equipment, that you get a customer that buys, they're going to come with 50 hertz components, and all of their values are going to be changed due to the fact that they have now been brought over and operated on a 60 hertz system. So go through all of those different calculations. For the rest, you're really just seeing a repetition of that same third column that we had, where it was the reactance. And the reactance column, once again, does not have any sort of subscripting to it. It just says X. It's up to you to determine whether a circuit is going to be inductive or capacitive. For this learning test, they're all capacitive. And then once you know what that is, to go and apply the proper component to it. For the rest, it's going to be Ohm's law, just rewritten for capacitive components, in this case XC components, or Watt's law, which is going to be this middle section over here. And then on the bottom one, these are just going to be your fancy Watt's laws, the derivatives that are going to be the roots and squares and the things like that. Go through the calculations, go through the self-test off of them. If you can answer everything in the self-test and inside of the calculations, you're good to go on the idea of this one.